Alright, so what is a jet stream? Jet stream is basically something that is always circulating that helps to push all of these air masses that I just discussed around the entire globe. Not just over North America, but over the oceans and then onto other continents as well. Alright, so let's talk about what it is. The first thing it's a very strong wind, which is concentrated in our tropopause. So just a few miles above us, above the Earth's surface. And what happens is that the jet stream is going to be basically a force that is going to continue to push different types of weather fronts as well as air masses throughout and spread them across the world. Alright. What tends to happen, however, is that the weather patterns, meaning again hot and cold, wet and dry, are basically based upon their positions. And depending upon where the jet stream is actually aiming and kind of pushing things will determine what type of weather or what type of weather front or air masses that we get over the course of a day, couple days or a week, and kind of what our pattern of weather that sets up. So like when you turn on Wood TV8, for example, and you see the 8-day forecast, they're looking into the trends in weather that are taking place, including the jet stream as it's pushing different air masses and fronts towards Michigan. That will help to determine exactly the weather we're going to have. The reason why the jet stream actually takes place is it's a process in which there's a meeting of air masses just underneath the tropopause. So when these two air masses meet, there's a difference in densities. And because there's a difference in densities, the pressure that is created due to the difference in densities helps to create the winds. So the winds themselves are created by a difference in pressure. So you could have one that's got high pressure and one that's low, and the greater the difference between the pressures, the faster the wind is going to travel. So on those really, really windy days that you might have once in a great while, you'll find that it's simply because that the pressure gradient, there's such a huge difference that it creates these really strong winds versus when you have a day that has very weak, calm, or no winds at all. It's because there's very little difference between the types of air masses that are coming in contact with one another. Again, continuing with what causes them, you're dealing with the warming of the actual air that takes place in our atmosphere. And what happens is, as this air continues to warm and rise, as it expands, it's going to start to then eventually cool down as it reaches a point in our atmosphere that is a little bit cooler than possibly the layer that it just came from. So as that happens, they're deflected by the Coriolis effect, again the rotation of the actual Earth. The flow of these boundaries creates the air masses that deals with the actual temperatures. And what happens is, because of the Coriolis effect and because of the layering of our atmosphere and how these air masses interact with one another, we get two different types of jet streams. We get a polar one and we get a subtropical jet stream. I'm going to take you up here for a moment. That's right, what these two are indicating right here. You have the one that's in blue, which is representing the polar one, and then you have the subtropical one right here. And again, these will determine exactly the types of moisture and the types of air masses that we actually receive over the course of time. And to give you an example as to what happened in the year 2012, more particularly in March, which was one of the warmest months ever recorded for March, and there were a number of records broken in the state of Michigan in 2012 in the month of March. And normally what we tend to find is that this polar jet stream usually is still close to Michigan, kind of making its way and wrapping around. So it's, you know, we're kind of in the middle between getting warm and still pretty cool, and that's why I tend to, in the transition from winter into spring, we tend to find that our temperatures of air, you know, are not too hot, not too warm, but we have our days once in a while. But in the year 2012, we had record temperatures that reached in the 90s for consecutive days, because what happened was this subtropical jet stream actually was higher, and the polar one was actually above Michigan up into Canada. So we were receiving air masses that we normally do not receive during that portion of the year. And it was because the subtropical jet stream had actually gone above Michigan, not staying below it, especially during the spring months. So that's what led to those really record warm temperatures in 2012 for the state of Michigan. in other states as well. Now, what's the importance of the jet stream other than the fact that it pushes air and it pushes air masses and brings us different types of weather? Well, the airline industry learned very quickly that the jet stream can actually help and also hinder flight times as airplanes were flying from one location to another. To give you an example, one of the storylines that goes is in 1952 there was a Pan Am flight from Tokyo to Honolulu, Hawaii, and basically again the flight time was reduced from an 18-hour trip down to an 11.5-hour trip. What that does is it allows for fuel consumption to be far less. And those of you that have flown lately or have noticed your parents who may have to fly for business, jet fuel is very expensive. So if airlines could then start to use the jet stream as a push of air to get from location A to location B, then that would help to reduce the fuel that's needed by airplanes to get from point A to point B. I don't know if that would necessarily mean that they would reduce your plane flight ticket, your ticket for your plane flight, but nonetheless, it's reducing the amount of gasoline or jet fuel that's needed. So within North America, as an example, time needed to fly from the east coast of the continent can be decreased by about 30 minutes if an airplane can actually fly with the jet stream. So I'll give you an example. I think I was a junior, maybe a senior in high school, so 17, 18 years old, and my grandparents' winter out in Arizona, Bullhead City, Arizona is where they actually used to go. And they would always fly into, well, they wouldn't fly, they loved to drive, but we would always fly into Las Vegas. Well, when we flew out to Las Vegas from Detroit Metro Airport, it took us between 3.5 to 4 hours to get out there. Well, on our return trip, we caught the jet stream and actually made it from Las Vegas to Detroit because the jet stream was lined up, and the pilot actually came on and said, just want to let you know that we caught the jet stream. We may have some turbulence, but we were flying at, and he gave a speed, and I want to say it was in the 500 or 600 miles an hour. I mean, it was very fast considering that's not a normal speed in which planes fly. It was because the wind was actually helping to push them. So anyway, we made the trip from Vegas back to Detroit in under 2.5 hours. And then when we arrived, we couldn't land because there was a snowstorm in Detroit, so we just continued to circle and circle and circle over and over and over again. But we had used so little fuel to get ourselves from Las Vegas to Detroit. We had plenty of fuel to burn, and we flew over Detroit Metro for almost 2 hours before they allowed us to land. So it's one of those things. It was a unique experience to fly that fast from that location, but nonetheless just to fly over Detroit because of the snowstorm. The other thing that it does, throughout the weather that it brings us, it's a rapid pushing air that helps again to push all the different types of weather across the entire world. The position and the strength of the jet stream basically are what helps meteorologists to predict what's actually going to happen in the future. So as I mentioned, Wood TV8 and other news organizations around West Michigan use the jet stream and information that they receive to help them predict what's going to happen over the course of the next couple days. And that's why some of the forecasts can be not so reliable after you get past day 1 or 2 because the jet stream is always changing. So it may look as if it's going to be headed towards us and pushing things towards us, and then eventually it changes because of the currents in our atmosphere. But nonetheless, that's what they're using it for, is to help predict the actual movement. The third thing I'll mention is climatic factors. The jet stream, because it's constantly moving air and air masses with temperatures and different types of moistures, it can actually help to change the pattern of weather. And if it changes it over the course of a long period of time, it can actually change the climate of that particular location. And remember, climate versus, say, weather, as we've discussed, climate is something that is going to take place over a 30-year period or longer, where weather is what you expect to have happen and what's taking place right now. Climate is a longer-term thing. But nonetheless, if the jet stream is continuing to change and monitor, and it will cause a change in the climate for that particular location. So, as a future idea for the jet stream, I was reading in Popular Science, and then a similar article showed up in Discovery magazine, where they were talking about how scientists were planning to actually harness the wind that is actually in the jet stream. And what they said and what they've been able to calculate is that the potential wind energy, so as these fast-moving air currents way above our head, miles up into our atmosphere, that only 1% of that air that's moving at the speed in which it's going would be needed to meet the world's current energy needs. Think about that for a second. If we were to physically be able to harness the wind that's traveling above us, a couple miles above our head, and then turn that into an energy source, you know, we talk about green energy, talking about, you know, things that we can do to reduce greenhouse gases and all these different types of technologies that are out there. What about wind? What about something that's already taking place that happens every single day, 24 hours a day, 7 days a week, 365 days a year? That could be a potential great idea if we can only learn how to harness it and turn it into an energy source. Just something to think about. So there's some more information about the jet stream, which you can actually see on this clip that I'm about to show you. But after this clip is done, if you do have any questions about the jet stream or the actual things that take place with air masses and the types of air masses, feel free to talk to myself or Mr. Fuzak. Here's a clip about jet streams.
Well, it's 7:49, time for another Ask Dirk segment.
Today's question that you sent in involves the jet stream. So, Dirk, what's the question?
Well, the question comes from Shelby from Newcastle, and her question is, it's a simple one. It's just, why is a jet stream called the jet stream? So the simple answer is, it's a stream of air that's moving faster than the surrounding air. But of course, we're not going to leave it at that. We have a lot more to talk about as far as the jet stream is concerned, because it's an important feature with our weather that we have. Now, here's the definition: a fast-flowing current of air located anywhere from 5 to 7 miles above the surface of the earth. That's the jet stream that we have, again, over us. It can be upwards of, a mile to 3 miles thick, the jet stream itself, and it can run anywhere from 1,000 to 3,000 miles. And you can see that aircraft love to find the jet stream because that just adds to their ability to go get there faster and, of course, use less fuel. And that's what you want. Of course, this day and age, if you're going to be flying around, it helps to save on money and energy. So the jet stream, there's actually two jet streams that we're concerned with here in the northern hemisphere. You have the subtropical jet stream. That's generally to the south of the United States, but occasionally it does affect or impact the southern half of the United States, including California. We sometimes feel the effects of the subtropical jet stream. But mainly it's the polar jet stream that we're concerned with and that we like to watch as far as the weather patterns that we have shaping up. This is really important because the colder air generally stays to the north of the jet stream, the warmer air to the south of the jet stream. When you have what's called a little trough or a valley, that's where we have areas of low pressure. And usually where you have that upper ridge that blows up there, you can see that's where we have the higher pressure and the warmer air that's usually associated with these two, again, areas of air to the north and to the south of the jet stream. Now, what's so important about this jet stream is it pulls along those weather systems, and this is what gives us our rain. And so we have these areas of low pressure that swing on through as those waves come through. That's what makes a cold front. And, of course, that's where we have the rain and the snow, and that's what we get during the winter months, and that's what we need a lot of. Of course, this time of year, we've been looking at conditions that have been dry for a little bit and then wet for a little bit. So this is what's going on. When we have our wet periods like we did in the month of February, we had a situation where we had a cutoff low. When the area of low pressure is cut off from the general flow of the jet stream, and so it just sits here off the coast of California, and if it's close enough, it swings that area of rain through, and that's what we had again in February. We had these waves of rain coming through. But what will happen also, and this happened in the through December and into January, the end of December and into January, you have an area of low pressure that's cut off from the jet stream. And then the high pressure builds in. In fact, we had in January 17th, we got up to 70 degrees because of a pattern similar to this. And so the jet stream is very, very important to our weather. It can also be bringing about some extremes, especially if you have that cutoff situation. So the jet stream, you can't see it. So I was thinking, what can I do for a demonstration? Well, I talked to our crack team here of engineers at KCRA, and this is what we came up with. I was just going to bring in my wife's hair dryer.
That would make sense.
That would make sense, but I talked to Dan Tracy and our team of engineers, and they brought this to me, and
it works pretty well. A notch.
We took it up a notch.
Right,
Here we go. We're going to turn it on. And what it is, we have a leaf blower, we have a tube, and we have the air coming out. Now, you can't see the air coming out, but you can feel the effects if I touch it, but also you can see our ping pong ball is being suspended in the air because of our jet stream of air being produced by our leaf blower. Now, it's interesting. I'm going to go ahead and just tilt this around. I don't know if you can see that. we can make it do circles. How fun is that? So there's our jet stream.